Hello, Georgi Romanic here. Today you will witness one of the most unique experiments on YouTube. We will demonstrate the operational principle of a Compton generator. If you don't know what a Compton generator is, then I encourage you to watch my video on the Coriolis force and Compton generator, or go and read some book or other material on that topic. In simple words, Compton generator is a simple device that can be used to demonstrate that the Earth is rotating, and that the Earth is also spherical, for all you flat Earth believers. Now, I told you that Compton generator is a tube like this one, and if you position this tube horizontally and you rotate it along the west-east axis, then if you have water in this tube like I do, there will be induced motion of the water thanks to the rotation of the Earth. Now, because the effect of Earth's rotation is so small on the tube of this size, on a loop of this size, it is almost impossible to measure the velocities that result as a consequence of the Coriolis force acting on the water. You would need much larger tube and or much better measuring device to notice motion of the water. But what we can do is to have this tube that I made at home, filled it with water, and put small particles of glitter inside that will serve as tracers, as the seeding material. So I have this tube filled with water. Inside there are these small particles of glitter, and instead of Earth rotating, I am the one that is going to rotate. So I will rotate around my axis with this tube horizontal, and when these particles stop moving with respect to my rotation, I will flip this for 180 degrees. When I do that, you will see something amazing. You will see that particles of glitter actually rotate in the opposite direction of my rotation. How is that possible? Well, you have to understand the concept of the Coriolis force, and preferably you should watch my video on Compton generator to properly understand that from both physical and mathematical point of view. Now here I don't know if you can see it on this video, but I made few marks, and particularly important are these two red marks. The distance between these two red marks is 2 centimeters. So I will use them as fixed marks to determine drift velocity of these glitter particles. To do all that, I am properly equipped, because here I have GoPro 10 that will be on top of my head. So when I start rotating, this GoPro is non-inertial reference frame that is rotating with me, and you will see the motion of this loop and particles in the loop from non-inertial reference frame, and that is GoPro on my head. At the same time, there will be another camera that will record me rotating, and that will be, of course, inertial reference frame. It will be much simpler to explain what I'm doing after I leave this desk and actually go and do it. So let us do it. So here we are. It's time to do the experiment. First, let's do it a few times qualitatively so you get the sense what I'm talking about. And what I'm talking about is, when I start rotating, we have to wait for this glitter that you now see from my GoPro to stop moving with respect to my rotation. And I have to maintain steady rotation as best as I can. And then I will flip this, and you will see the effect of the Coriolis force. So let's do it. I'm rotating, look, At this point already, this glitter is stationary with respect to my rotation. Now I flip this, and you can see the motion, clearly the motion of the glitter in this tube. I flip it again, you can see how it rotates in the direction opposite of my rotation, and that speed of rotation of the glitter is approximately 2 times my rotation. Look, pook. Very well, now it's time to do this experiment for real, and that means I will try to be as steady as I can in my rotation. GoPro camera will record the motion of this tube and the glitter inside of tube when I rotate it, and these lines on the floor we can use as a reference afterwards to calculate my angular velocity of my rotation. So let's do it. As you can see, I'm doing several of these experiments because I want to have several samples that I will process. Hopefully in some of them I will have good results that we will be able to use to calculate diameter of this tube. Now it is time to process our data, and here I already found a part of the video that seems to be promising in terms of following these particles. I will play it now for you. So I am rotating right here. Now as you can see, when I say right here, you don't see that much. But if we go back and now I play this frame by frame, as you can see now, here, this black particle over here is the one that we are interested. In this frame it is here, and in the next frame it is already here. So now I will crop these two frames and let's analyze them quickly in Paint. Here are the two frames that I just played for you in the video. Our particle of interest is right here in frame number 1, and it is right here in the frame number 2. So if I take this line and I approximately connect the distance from the top of this particle to somewhere here where it was in frame 1, notice that it's approximately here, and I take this line and I move it here, you will see that this distance that the particle traversed in one frame is approximately, I would say, 1.7 centimeters, because the distance between these two red lines is 2 centimeters. So this would be approximately 1.7 centimeters or so. So let us write that down. So 1.7 centimeters in one frame. So we will use this to calculate drift velocity for this particle. However, this is not the end, because we need to calculate also the angular velocity of me rotating. So let's go back to the video and calculate that. So to calculate angular velocity, I will track my rotation for 90 degrees. And I will start from this point, I would say, when I am parallel to these lines on the floor. And now I am going to count frames. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now we can see I am parallel to these lines that are perpendicular to the one to which I was parallel when I started. So we can conclude that I rotated for 90 degrees in 18 frames. Lastly, I also know that my camera records at 24 frames per second, which means we can now go from frames to times in seconds. Let us start by sketching this problem. What we have here is a loop of, for now, unknown diameter, let's call it D, that is rotating around some axis of rotation, which is basically center line of my body, and this entire loop is being rotated with some angular velocity omega George Romanich, my angular velocity. At the same time, as I am rotating this loop, I also flip it, let's say around this axis, for 180 degrees. And that rotation around the 180 degree axis results in drift velocity. And from my video on Compton generator, we know that that drift velocity caused by the Coriolis effect is 2r omega e sine phi. But in our theory on Compton generator, omega e was angular velocity of the planet Earth and phi was latitude. In this case, if you look at this schematic z-axis coming out of the page, you can see that this is basically a rotating disk. And the flipping of this tube is carried out through the axis that is parallel to the plane of rotation, plane of the disk. That would be like rotating it while standing somewhere around the northern or southern pole. At any rate, in our experiment, this phi is therefore 90 degrees, pi over 2. So consequently, this sine phi is 1. Of course, omega of planet Earth in our experiment becomes omega of George Romanich. And r was radius of this loop, so 2r is diameter. So combining all these, we get that drift velocity is diameter times omega George Romanich. Or from here, one can easily calculate, therefore, that diameter, and I will call it c, calculated diameter, is drift velocity of the particles divided by omega George Romanich. Excellent. Now what we need to do is determine drift velocity and omega dr from our measurements, plug in the values, and then compare the calculated dc versus the measured value. Well, in the video that I just processed, you saw that the drift distance, let's call it LD, was 1.7 centimeters, or consequently 0.017 meters. That was the drift distance that a seeding particle traversed in one frame. But I don't need frames, I need time in seconds. So, I know that my camera is recording this whole thing with time resolution of 24 frames per second. So that means 24 frames are recorded in 1 second, which means one frame that it took this particle to traverse the distance LD, one frame is drift time of seconds. Or we can see that this drift time is therefore equal 1 second times 1 frame divided by 24 frames. So frame and frame cancels, and we get that TD is equal 1 divided by 24, and that is 0.042 seconds. Now from TD and LD, I can calculate that this drift velocity is simply LD divided by TD, or if you divide these two numbers, you will get approximately, with rounding of numbers, 0.41 meters per second. So we calculated drift speed that goes into this equation. Now we need to calculate omega dr. Well, by definition, angular velocity of anything, in this case George Romanich, is equal angle divided by the time it took to traverse that angle. Now, the angle that I traversed was pi over 2, 90 degrees, and I did it in some time t George Romanich. Now, what is t George Romanich? Well, you will remember it took me 18 frames to traverse 90-degree angle. So in this equation over here, if I want to calculate TDR, instead of 1 frame, I plug in 18 frames, and I would get that T George Romanich is equal 18 frames divided by 24 frames times 1 second equals 2.09 second minus 1. So this is angular velocity of my rotation. Now, combining these two values and plugging it into this equation, we can see that D calculated is equal VD 0.41 divided by omega dr 2.09, and that is equal 0.196 meters, or if we round it up to 2 decimal digits, that would be 0.20 meters, or that is of course 20 centimeters. Punchline: measured value is equal how many centimeters? Let's see what number will end up here based on our measurements. Here is the loop, and here is a ruler. The ruler here says 21.5 centimeters. I hope you can see it. 21.5 centimeters. 21.5 centimeters. And this, my dear viewers, is absolutely amazing result. Keeping in mind that this theory of drift velocity that we developed had so many simplifications, we are not taking into account that there is velocity profile in this tube, that velocity is the fastest close to the center, and then it has to be 0 at the edge due to the no slip boundary condition. Neglecting turbulence and neglecting aerodynamic effects of our seeding material, because our seeding material was basically small planks, small plates of paper, of glitter, which have very sharp corners, and these sharp corners tend to separate the flow and create all kinds of turbulent motion. Neglecting variable angular velocity of my rotation, which is unavoidable because I'm using my legs to rotate, to push around, and therefore this omega dr cannot be smooth. In other words, to be technical, I am introducing Euler force into the whole problem, and also very crude measurements of the drift distance, drift time, and so on and so on. With all these simplifications, we get astonishingly similar results for measured and calculated value of the diameter of this loop. In my not so humble opinion, this is one of the most complete demonstrations, quantitative demonstrations of the Coriolis effect on YouTube. Moreover, this is a simple apparatus that all of you can prepare at home, because all you really need is tube, connector, seeding material in the tube that I hope you can see, seeding material in the tube. In my case, these small particles of glitter, and the entire apparatus is not more than $20, and you can do it on your own. So play with it and test the Coriolis effect in the comfort of your house. Of course, this Compton generator with glitter inside is very good device, and it can be used also as a nice necklace. So I quite often wear it as a necklace when I go to work, because it's very nice, right? And I also often have it in my pocket, because you never know who will ask you for a quick demonstration of Compton generator and the fact that the Earth is rotating. Until next video, goodbye.